somewhere beneath the Egyptian desert, inside a 4,500-year-old pile of limestone blocks, there is a chamber that behaves like nothing else on Earth. Physicists pointed radio waves at the Great Pyramid of Giza, ran the numbers, and found something they did not expect. Under the right conditions, the pyramid can grab electromagnetic energy out of the air and concentrate it, funneling it into its internal chambers and into the empty space beneath its base. This is not a legend whispered by tour guides. It is not a claim from a pseudo-archaeology documentary. It is a real peer-reviewed physics finding, published in a respected scientific journal. And it is one of the strangest side effects of ancient engineering ever measured. Stick with me, because the real explanation is more interesting than any myth. And by the end you will understand exactly what scientists proved, what they did not prove, and why the internet keeps getting this story wrong. Let's start with who actually did this work, because that matters. In 2018, a team of physicists from ITMO University in St. Petersburg, Russia, working alongside colleagues from the Laserzentrum Hanover in Germany, decided to treat the Great Pyramid the same way they would treat a nanoparticle. That sounds like an odd comparison, but it is exactly the point. In the world of nanophotonics, scientists routinely study how tiny particles interact with light and radio waves, figuring out how those particles absorb, scatter, or concentrate electromagnetic energy, depending on their shape and size. The Great Pyramid, despite being roughly 146 meters tall and built from over 2 million blocks of stone, is still just a geometric shape sitting in a field of electromagnetic waves, whether that field comes from sunlight, radio broadcasts, or background radiation. So the researchers asked a simple but ambitious question. If you modeled the pyramid the same way you would model a nanoparticle, scaled up to enormous size, what would happen when radio waves of a specific wavelength hit it? To answer that, the team built a computational model of the pyramid using its real dimensions and the known properties of the limestone it's built from. They then simulated what happens when the pyramid is struck by radio waves whose wavelength is comparable to the size of the structure itself. This is called a resonance condition, and it's a concept you actually experience all the time without realizing it. Push a child on a swing at just the right rhythm, and the swing goes higher with very little effort. Sing a certain note in a shower stall, and it seems to boom. Both of those are systems responding strongly to energy delivered at a matching frequency. The pyramid, it turns out, does something similar with electromagnetic waves. When radio waves at that resonant wavelength strike the structure, the model showed the energy doesn't scatter away evenly. Instead, it concentrates in specific regions. Inside the pyramid's internal chambers, including the area associated with the king's chamber, and in a pocket of space located beneath the pyramid's base, roughly where an unfinished, never completed chamber sits underground. I want to be precise about what that actually means, because this is where a true story gets exaggerated into a false one. The researchers were not standing inside the pyramid with instruments detecting mysterious energy beams. This was a theoretical and computational study. They built a mathematical model based on physics that engineers use every day to design antennas, solar panels, and sensors, and they ran simulations. The scientists themselves were upfront that they made assumptions to get there, including treating the pyramid as built from uniform limestone with no unknown internal cavities, since the exact composition and hidden structure of the pyramid is still not perfectly mapped even today. Andrei Evliukin, one of the senior researchers on the project, said plainly that they had to use assumptions to make the modeling possible. This is honest science, a simplified model of an extremely complicated real object, used to reveal a genuine physical principle, rather than a definitive claim about supernatural energy pulsing through the stones. So what is the principle they revealed? In essence, the Great Pyramid size and shape happen to fall into a range where it can act as what physicists call a resonator for certain radio wavelengths, meaning its geometry is capable of concentrating electromagnetic energy the way a magnifying glass concentrates sunlight into a single bright point, except with radio waves instead of visible light, and with a pyramid instead of a lens. Multipole resonance, the specific term used in the published paper, describes the way a structure's shape causes electromagnetic fields to build up in particular patterns and locations rather than spreading out evenly. It is the same broad category of physics used to design certain types of antennas and metamaterials, artificial structures engineered to bend or trap electromagnetic waves in ways natural materials normally can't. What the Giza study showed is that, by coincidence of its scale and geometry, the largest pyramid on Earth happens to sit in a size range where this kind of resonant energy concentration becomes possible for certain radio frequencies. And here is the detail that tends to get left out whenever the story goes viral. The researchers were explicit that this appears to be a coincidence, not evidence of intentional ancient engineering. There is no indication in the historical or archaeological record that the builders of the pyramid, working around 2560 BCE, understood radio waves, resonance, or electromagnetism in any scientific sense, since those concepts wouldn't be formally understood by human civilization for another 4,500 years. What the ancient Egyptians clearly did understand, and understood extraordinarily well, was geometry, proportion, and monumental engineering on a scale that still challenges modern construction logistics. The pyramid's dimensions were almost certainly chosen for religious, symbolic, and structural reasons tied to their beliefs about the afterlife and their sun god, not because someone was optimizing for radio wave resonance. The electromagnetic behavior is a byproduct of getting the size and shape right for entirely different reasons, discovered thousands of years later by physicists using tools the pyramid's architects could never have imagined. Why does any of this matter, beyond being a fascinating trivia fact? Because the research team wasn't just doing this to satisfy curiosity about ancient history. Their real goal was forward-looking. By understanding how a large pyramidal structure concentrates electromagnetic energy at specific resonant wavelengths, the scientists want to apply the same underlying physics at a completely different scale, the nanoscale, meaning structures thousands of times smaller than a human hair. If you can design tiny pyramid-shaped particles out of the right materials, you can potentially replicate this energy-concentrating effect for light in the optical range, rather than for radio waves. That has real practical value. Concentrating light efficiently is exactly what you want for two major technologies. Solar cells, where capturing and focusing as much light as possible directly improves how much electricity you can generate, and nanosensors, tiny devices used to detect chemicals, biological molecules, or other signals at incredibly small scales, where concentrating light into a small area can make the sensor dramatically more sensitive. In other words, one of the oldest and most mysterious structures on the planet may end up quietly influencing the next generation of clean energy and detection technology, not through ancient magic, but through a shared mathematical principle connecting an enormous stone monument and a particle smaller than a virus. Let's slow down on the mechanics for a second, because the why here is genuinely elegant once you strip away the mystique. Every physical object, from a tuning fork to a guitar string to a stone monument, has natural frequencies it responds to more strongly than others, based purely on its size, shape, and material. Engineers exploit this constantly. A radio antenna is essentially a metal rod or wire cut to a very specific length, so that it resonates with the radio waves it's designed to receive or transmit, which is why old car antennas and cell towers come in particular lengths, rather than arbitrary ones. Concert halls are shaped and sized with resonance and acoustics in mind, so that sound waves reinforce each other in pleasing ways instead of canceling out or creating dead spots. The Great Pyramid, simply by being an enormous, geometrically regular structure made of a consistent material, happens to have natural resonant behavior for electromagnetic waves of a length proportional to its own dimensions. The same way a wine glass has a particular pitch it rings at when you run a wet finger around its rim. The research team calculated that for the pyramid, that resonant behavior falls within the radio wave portion of the electromagnetic spectrum, specifically wavelengths measured in meters, which is a range well below what human eyes can see, but well within what modern communication equipment routinely generates and detects. It's also worth understanding what multipole resonance, the specific term from the published paper's title, actually describes, because it's not just a fancy label. When an object interacts with an electromagnetic wave, the resulting field around and inside it can be broken down mathematically into different components, sometimes visualized as increasingly complex patterns of positive and negative charge distribution, starting with the simplest pattern and moving to more intricate ones. Physicists call these dipole, quadrupole, and higher-order multipole contributions. The Giza study identified which of these patterns dominate the pyramid's interaction with resonant radio waves, and traced how those patterns funnel energy toward the internal chambers and the space below the base rather than letting it dissipate outward. This is precisely the kind of multipole analysis nanophotonics researchers use to design metamaterials, engineered materials with electromagnetic properties that don't occur naturally, which is exactly why a team accustomed to working with nanoparticles was well suited to analyze a 5,000-year-old monument in the first place. The tools transferred directly, even though the scale changed by a factor of roughly 1 trillion. It's worth taking a moment to appreciate just how strange that connection is. The Great Pyramid was completed during the reign of the pharaoh Khufu, built as a tomb and a monument meant to help secure his passage into the afterlife, according to ancient Egyptian religious belief. It has stood through the rise and fall of the Old Kingdom, through Roman occupation, through the spread of Islam across North Africa, through Napoleon's expedition to Egypt, and now into an age where physicists model it on computers the same way they model particles engineered in university laboratories. It is genuinely one of the only structures on Earth old enough and large enough to bridge that kind of comparison, ancient monument, and modern nanotechnology research in a single scientific paper. Now, because this story involves a Great Pyramid, it inevitably gets tangled up with decades of older, far less scientific claims, and it's worth separating fact from folklore here, since that separation is exactly why this particular study stands out. For nearly a century, there has been a popular but scientifically unsupported idea, sometimes called pyramid power, the claim that pyramid-shaped objects can preserve food, sharpen razor blades, or channel some kind of mystical life energy simply because of their geometric form. Those claims were never based on rigorous, peer-reviewed experiments, and controlled testing over the decades has consistently failed to support them. The ITMO and Laser Zentrum Hanover study is a completely different category of claim. It's grounded in established electromagnetic theory, the same physics behind Wi-Fi routers, radio antennas, and satellite communication. It was peer-reviewed, and it was published in the Journal of Applied Physics, a legitimate scientific journal that specializes in exactly this kind of engineering physics research. The distinction matters enormously. One is a modern testable claim rooted in decades of established physics, and the other is an unverified belief that has circulated since long before anyone modeled the pyramid mathematically. This video is about the former. There's also a nice bit of historical irony buried in this discovery. Modern researchers have spent decades using increasingly advanced technology to peer inside the Great Pyramid without disturbing a single stone. In recent years, an entirely separate international team used cosmic ray muon detectors, instruments that track subatomic particles raining down from space, to identify a large hidden void deep within the pyramid structure, a space now generally referred to in scientific literature as a previously undetected internal cavity above the Grand Gallery. That muon discovery and this electromagnetic resonance study are different projects using completely different methods, muons versus radio wave modeling, but they both represent the same broader trend. Cutting-edge physics being turned toward one of humanity's oldest surviving large structures, revealing new layers of understanding about a building that has already been studied for centuries. It also raises a fair question a lot of viewers ask at this point. Could this electromagnetic resonance effect ever be tested directly, rather than just modeled on a computer? In principle, yes, and it's not far-fetched. Researchers could, in theory, use ground-based radio transmitters tuned to the calculated resonant wavelength and take field measurements around and inside the pyramid to see whether real-world energy concentration matches the model's predictions. Similar in spirit to how the muon detection teams physically placed instruments inside and around the structure to map density differences in the stone. As of the published research, that kind of direct field experiment doesn't appear to have been carried out yet, which is an important distinction to hold on to. What we have is a rigorously calculated theoretical prediction from a legitimate physics team, Not yet a confirmed real-world measurement taken with antennas at the site itself. That's not a weakness in the science. It's simply where the research currently stands. And it's exactly the kind of detail that separates a responsible retelling of this story from the exaggerated versions that show up as Ancient Pyramid Emits Mystery Energy Field headlines. That distinction also explains why serious science journalists and outlets covering the story back in 2018, including Physics World and Science Alert, were careful to frame it as a computational and theoretical result rather than a confirmed physical detection. The scientists were not claiming to have found some previously unknown power source inside the pyramid. They were demonstrating, through legitimate and peer-reviewed modeling, that the pyramid's geometry places it in a genuinely interesting category of electromagnetic behavior, one that happens to be useful for future nanotechnology research, regardless of who built it or why. So where does that leave us? The Great Pyramid of Giza, according to a peer-reviewed 2018 physics study from ITMO University and the Laserzentrum Hanover, can theoretically concentrate electromagnetic energy from radio waves into its internal chambers and into the space beneath its base, when those waves hit the structure at a wavelength that matches its resonant size. This happens because of the pyramid's specific geometry and scale interacting with electromagnetic theory, the same physics that governs antennas and modern nanotechnology, not because of any mystical property or intentional ancient design for that purpose. The researchers themselves describe the effect as coincidental, a byproduct of getting the proportions right for religious and architectural reasons that had nothing to do with radio waves. And now, scientists hope to borrow that same geometric trick and shrink it down to the nanoscale, potentially improving solar cells and sensors using lessons learned from a monument that has already stood for 4,500 years. There's one more layer worth sitting with before we wrap up, and it's about scale itself. The Great Pyramid originally stood at roughly 146 meters tall when its outer casing stones were intact, making it the tallest human-made structure on the planet for over 3,800 years, a record that stood until the completion of Lincoln Cathedral in England in the 12th century. Its base covers over 5 hectares, and estimates suggest it contains somewhere between 2 million and 2.3 million individual limestone and granite blocks, some of the largest weighing many tons, quarried, transported, and stacked with a level of precision that still impresses structural engineers today. When physicists say they modeled the pyramid the way they'd model a nanoparticle, they are compressing an almost unimaginable feat of ancient logistics and labor into a set of mathematical inputs: height, base width, material density, angle of the sides. The fact that those inputs run through the same equations used to design modern antennas and solar cells, produce a genuine, calculable resonance effect, is a reminder that physics doesn't care about the era or the culture that built something. Geometry is geometry, whether it's shaped by 21st century engineers optimizing a nanoparticle or by ancient Egyptian architects optimizing for the afterlife of a pharaoh. It's a genuinely rare kind of story, one where verified, published, peer-reviewed science turns out to be just as strange and compelling as any myth, without needing a single exaggeration to make it interesting. The Great Pyramid was never designed to be an antenna, but under the right conditions, according to real physics, it can act a little bit like one anyway. And that fact alone says something remarkable about how mathematics, geometry, and the physical universe connect structures separated by thousands of years and unimaginable differences in scale. If a story like that is worth knowing, there's a good chance the people around you haven't heard it yet, so it might be worth passing along.